Why, hello everyone. Welcome to CS 3750's Group 12's presentation on blockchains. I am your host, Gareth G. Waughan, and joining me are the talents of Ricardo Garcia, Susan Lee, Arturo Pan, and guest starring Blake Sanchez. So, Section 1. What is the blockchain? Is this something to do with Lego blocks and daisy chains? No. No, it isn't.
Looking at the origins of blockchain, in 1982, David Chum, who proposed the first type of blockchain, of course, in 1982, is also credited with developing most of the components of a blockchain. So David Chum is a giant in the realm of computer security, and not surprisingly, given the subject matter of the presentation and its implications, also cryptocurrency. In 2022, in reference to blockchain, of course, David Chum describes it as it can be used to better sell products or better find answers, but can also be used to better propagandize, attract dissidents, which is a person who opposes official policy, as well as control populations. Once again, just showing the value and impact of this computer technology. Looking at 1991, and as well as continuing with the origins of blockchain, we have Stuart Hauber and W. Scott Stornetta, who developed a digital timestamp in 1991, which is equivalent to the fingerprint of a digital file. So the two met at Belcore Labs in the 1990s. Both were scientists, and interesting to their profession, they're actually allowed to pick their own research projects. Scott was the one that kind of took initiative here, and he wanted to look at a problem that had to do with the authentication of digital documents. The question he asked himself was, how could you be sure the version you were looking at had not been altered from its original? Which is super important given the private sector, as well as implications for sending and receiving government documents, for example. Ensuring the information received is original and authentic is crucial for an efficient and trustworthy technological future. In 1992, Hopper, Stornetta, and Dave Bayer. Dave Bayer is an American mathematician, most noted for his contributions in algebra, but of course as well as improving digital timestamping. They improved upon digital timestamping by using hash and Merkle trees, which is go ahead and display it over here on the right-hand side. And then Dr. Hauber worked at Belcore Labs, of course, more specifically in the Communications Research Department, prior to founding Surety, which was founded in 1993, which was the first company to offer commercial deployment of blockchain. Continuing on with the origin of blockchain, in 1993, Cynthia DeWerck and Moni Noir developed Proof of Work, of course, in 1993, which dealt with the difficult computational puzzles. And a proof of work is described as a system that requires a feasible amount of effort in order to deter frivolous computing power. Hal Finney adapted this in order to secure digital money using the SHA-256 hashing algorithm. And over here on the right-hand side, we have a diagram of proof of work, which a user requests a service, data or file is chosen, a challenge is sent back, and then once solved by the user and the response is sent back, upon verification, then that service or file is then granted for that initial user. And then Hal Finney, interesting, and 13 years ago, on January 12, 2009, the founder of Bitcoin actually sent Hal Finney 10 Bitcoins and the first ever Bitcoin transaction ever recorded, using this technology, of course.
What is a blockchain? Blockchain is a decentralized digital ledger where the data is stored in blocks and cryptography links the blocks of data together. The information with these blocks is immutable, it's difficult to change, it has to be because of proof of work, and the information is encoded using a hash tree, also uses a hash function to generate a unique hash value. The digital ledger is public, so there's no third-party involvement or it isn't required when checking the integrity of the data. This relies on a peer-to-peer network. The users check the information and make sure that it is all correct. Because of this peer-to-peer network, the information is stored across different computers that act as a database. And it's popular in cryptocurrencies. Bitcoin was the first cryptocurrency to use blockchains, and since then, cryptocurrencies had followed that format or some other iteration of blockchain itself. So what is the block and the chain? Blockchain consists of three components. It's the data, hash, and the hash of the previous block. So the data and the hash, that is the block. And the block essentially stores the data or the information. The first block in there is what's called a genesis block. And it typically has like templates to store. A template that the rest of the blocks will follow to store the information itself. So, for example, in a cryptocurrency, it would be like the name of the person that owns the cryptocurrency, how much cryptocurrency, and any transactions relating to that cryptocurrency itself. And then you also have hash, which is a digit fingerprint. The hash value is always unique, and if there are any changes within the block or the data itself, it changes that hash value. And that has to do with the hash function. The hash function is designed to make a new hash value if any of the information changes. And then you also have the hash of the previous block, which is the chain. It's what links everything together. So each block holds a unique hash of the previous block, and it's that hash value itself that links one block to the next. And it could go all the way back to the very first block, where the first block itself it doesn't have the hash of the previous block. What it'll do one of two things. It'll have like some pseudo number that doesn't link to anything, or it just won't have the hash of the previous block. But other than the first one, the rest of them will have it. Then we have the blockchain and a traditional database. Blockchain is decentralized and traditional database is centralized. So for decentralized, the information is stored by users within a network, and control and verification of data is maintained by users. It has to do with a peer-to-peer network, and it's a costly method of storing information. Reason for this is because it's multiple users acting as a sort of database, like a pseudo database for the blockchain. There's a lot more computers involved, and there's also data mining, and all this you take that in consideration. Like a traditional database, it's a lot more expensive just because of the amount of computers required involved in blockchains. It's difficult to hack the information. It has to do with like the digital fingerprint with the hash function, and also since it's a peer-to-peer network and users are checking it, there's always multiple users checking the integrity of the information. If any information changes, it will be detected. And the information can be, even if like a hacker goes up changing it, it's not like something that can be changed instantly. It'll take some time to solve like a cryptography puzzle. And the network is open to the public, and anybody can connect to verify the integrity of the information itself, and there is no third party involved in it. Now for centralized, this is where the information is stored at a central point or a database. Since it's stored at a central place, it usually means there's like a third party involvement. Databases are handled by third party. Since it's handled by a third party, like users just can't check or verify the integrity of information. So if the third party wanted to change any of the information in the database, it could be really easy for them to do that. If like the person using the database, like the company that was using it with a third party, they're not like keeping track of all the data coming in and out. They don't have records. There'd be really no way to go back and check that. Because it's like a central location, it's prone to hacking. Once you get into the database network, you can go ahead and change information. And then information storing is cheaper. Again, this has to do just because of the amount of computers that go into like a decentralized network compared to like a central location, a database. and the network isn't open to the public. It's something that's private to that third party and the users themselves.
I'm going to explain to you how blockchain works. As explained before, a single block is just a collection of data that is uniquely identified through the hash value, which we can think of as the fingerprint of a human. On the other hand, the blockchain forms the chain by connecting all the blocks using the hash values from previous blocks. Now, having that understanding of blockchain, how exactly does a blockchain system work in a real-life application? Like we explained before, unlike traditional databases, a blockchain is a distributed database that is shared among the nodes of a computer network. What does that even mean? It means that every computer that belongs to the blockchain system will receive a copy of all the records that are shown in the picture. In the picture, we have four computers, or nodes, or people, however you want to call it. Each computer will receive a copy of the database, which are the three blocks connected by the chains. Now, with that said, let's say our blockchain stores information about student records. If a new student will be admitted into the school, every computer in the blockchain will then verify the integrity of the data, meaning that they will check that the student record doesn't contain any false information before admitting it into the school. Once everyone checks the record, then they will come up with a consensus, which means that they will either accept or reject the new data. And that is a very important part about blockchain. Computers must agree on a transaction, and that process is called consensus, as shown in the slides on the right picture. How does that work? Well, remember our P2P network lecture? The way blockchain works is basically through the P2P peer-to-peer protocol. Each computer works with one another, and there's no need for a middleman. For example, if computer A wanted to communicate with computer B about a new student record, then computer A will say, hey, I agree and I accept the new student record. And then computer 1 will tell the results to computer B, and then B will also come up with the conclusion, either accept or reject. And both of them will come up with an agreement. If more than 50% of the people accept the new record, then it means that the student record will be admitted into our school because more than 50% of the computers agreed on accepting it. There are many consensus mechanisms: proof of work, proof of stake, practical Byzantine fault tolerance algorithm, and many more algorithms. Proof of work is one of the most popular consensus mechanisms, and it is also used in Bitcoin. It is used as follows. First, a cryptographic puzzle must be solved. Miners compete to solve the puzzle first. In our examples for admitting student records, the student records are the puzzles. Basically, a student will arrange and submit the application to the school, and then the school will treat that application as the puzzle, where miners compete to solve the puzzle first. Then, once the application is ready to review, that application or solution is shared with other computers on the network. And then the network will finally verify and come up with a consensus that, hey, is this record okay to accept? They will either agree or reject the student record. And that's how proof of work works.
Diving further into how a blockchain works, more specifically how a proof of stake blockchain works. Proof of stake protocols are a class of consensus mechanisms for blockchains that work by selecting validators in proportion to their quantity of holding and an associated cryptocurrency. This is done to avoid the computational cost of proof of work schemes. This may seem complicated, but it isn't. Looking at the diagram in the list below, we have node, validator, stake, validator choice, transaction and block, blockchain sharing, and finally validation. It is based on the stake or the amount of money decided by the validator. One will block or freeze an amount of money at will inside the system to be then chosen to forge the block. The more money that is frozen, the higher the chance to be picked as the validator node. The stake works as an economic incentive, deterring the validator node from validating or creating malicious transactions. If the network finds a fraudulent transaction, the validator node loses part of its stake, as well as the right to participate as a validator in the future. So as long as the stake is higher than the reward, the validator that tries to game the system would ultimately lose more than what they would have earned. Validator nodes become responsible for verifying, voting on, and maintaining a record of transactions. They act as a moderator for the stake protocol. Why would someone want to be the moderator or validator node for that matter? Is it profitable? Yes. Validators charge a commission on the rewards generated by the stakes they hold, anywhere from 1% to 10% typically. Proof of stake cuts out the need for complex computations, so it beats proof of work when it comes to energy efficiency. Now Susan is going to go over and show you some applications of blockchain.
In the real world, companies that must outsource their cybersecurity cannot differentiate between those that are making false claims or not. After all, cybersecurity companies can make as many claims as they want, such as performance, effectiveness, detection capabilities, and many more. However, it can often be difficult to disclaim. But with blockchain technology, customers outsourcing their cybersecurity can verify whether attacks are being detected and are legitimate.
So, you want to solve problems with blockchains, do you? You want to use their transparency and use it to apply to different apps of blockchain in society. Well, I may tell you for one thing, blockchains are both transparent and secure to use. For you see, blockchains are open source software. Anyone can code them. Anyone can suggest changes to them. They offer a ubiquitous control to changes and upgrades to a certain system. For example, if someone doesn't like how Dogecoin is operated or made, they can offer upgrades to change it to, say, I don't know, Catcoin. There's a democratic involvement in developing blockchain software. And so, that is why cryptocurrency is so popular. It is currency, not by the government, but for and by the people. Its popularity is further emphasized by the security it offers. Authentication required, please. Because each block in the chain carries a unique hash code related to that block. Despite this one-to-one secure system, the code is related to the block, while a different block has a different code. But this makes it very easily distinguishable if any changes in the code is made. For information,
There are 3 examples I would like to go over which uses blockchain technology, and they are real-world examples. The first example falls under cybersecurity, and their startup is called GuardTime, as you can see in the first picture on the left. This startup uses blockchain to create keyless signature systems, which are now being utilized to protect the health information of 1 million Estonian individuals. The next real-world example is under healthcare, and the business is called GEM. And this business is collaborating with the Centers for Illness Control and Prevention to place disease outbreak data on a blockchain, which it claims would improve disaster relief and response efficiency. The last real-world example would be a government-related, and this is actually located in Dubai, and Dubai is aiming to be the first blockchain-powered state in the world. Officials from 30 government agencies organized a group in 2016 to look for prospects in areas such as health records, shipments, company registration, and dispute diamond prevention.